before we get into today's lesson, we're going to do a quick review of what we did last class. So we looked at acids and bases. And we said that acids are substances that donate hydrogen ions when dissolved in water. We also said that it ranges on the pH scale from 0 to 6. Examples are orange, lemon, lime. So let us look at bases now. We say that, well, we know that bases are the opposite of acids. So when the acids donate the hydrogen in water, the bases will accept the hydrogen when dissolved in water. And on the pH scale, the bases ranges from 8 to 14. And some soap, Colgate, bleach, etc. So for today's topic, we are going to look at strong and weak acids and bases.
Okay, our objectives for today are that you'll be able to identify some examples of strong and weak bases, bases, and also you'll be able to state the difference between strong acids and weak acids, and strong bases and weak bases.
Okay class, so since you are familiar with the term acids and bases, can you tell me what you think are strong acids? Take 1 minute to think about it, please. For your response, now I will explain how you can identify strong acids from weak acids and strong bases from weak bases using the pH scale. So I'm going to draw it on the board now. Scale. We're going to start from 0. So we said in the last class that acid ranges from 0 to 6 and bases ranges from 8 to 14. And 7 is neutral. So these and okay. Example of a neutral substance is water. Okay. So on the pH scale, strong acids ranges from 0 to 3. So I'm just going to put an arrow here showing where the strong acid starts and where they end. So since here is strong acids, from 4 to 6 will be the weak acids. So the closer the acids to the neutral point, the weaker the acid will become. Now, so from, as I just said with acids, the closer it is to the neutral point, the weaker it gets. So from 8 to 11 will be the weak bases because over this side is this. And from 12 to 14 will be the strong bases.
Just to add what Ms. just said there, it will be strong bases because it is farther away from the neutral point.
Examples of strong and weak acids that are found at home or in your environment. Strong acids will be like hydrochloric acid, which is weak acids. Those would be the common one that you can find at home, like vinegar. Acids are very harmful, so you won't find them at home. And weak bases would be like soap and Colgate and so on. Okay, so an example of a strong base will be glue. Okay, so I see Mary has her hands up. Do you want to ask a question? Okay, so Mary is asking where can hydrochloric acid be found? So hydrochloric acids can be found either in a hospital or in a science lab.
Okay, just to add a little to what Mrs. Happy here on the board. Now, if we want to neutralize the acids or bases, okay, for example, bases, we need a substance from acid or acidic substance in order for it to be neutralized. For example, let's look at bases. So we know that bleach is an example of strong bases. Now, if we want bleach to be neutralized, we use one of the substances from, or an example of a substance from acids. For example, it can be hydrochloric acid or vinegar. But in this case, let's use vinegar as an example. So, if we add vinegar to bleach, when mixed together, it becomes neutral, meaning that it will move from being a strong base, which is from 12 to 14, from that range, going back from 13 straight down to 7. That's the neutral point. Are there any questions so far? Okay, just a little recap of the pH scale before we move forward. Now, from 0 to 6, it's acid. From 8 to 14, we have basic. Now, 7 on the pH scale is neutral. That's the neutral point. From 0 to 3, as can be seen here, we can consider this to be strong acid. And from 4 to 6, weak acids. Now, on the other side, we can have from 8 to 11, we have weak bases. And from 12 to 14, strong bases. Now, just a little, maybe something that you can take home as a little reminder or so that if in the next class you look at the periodic table, you'll be able to remember it easily. Now, on your left hand, you can find acid. On your right side, you find bases. Let me go that back again. On your left side, you have acids from 0 to 6. On your right side, you have bases from 8 to 14. Are there any questions whatsoever so far? If not, we'll move on to the properties of strong acids and weak acids. Miss will help you with that.
Okay, so the first one here we have are the strong acids over the side versus the weak acids. So the first point here, it says strong acids are molecules that completely dissociate into their ions found in water. So the word dissociate means when it is placed in water, it completely breaks down and the ions separate. The second point, it says that the pH of a strong acid solution is very low. So like Miss explained on the pH scale before that, from 0 to 3 are strong acids and those are low numbers, so the solution on the pH scale will be very low. And the last point, it says that it releases all the hydrogen ions to the solution. So when it is placed into water, it releases all of the hydrogen ions, so it is completely dissociated. And an example of a strong acid would be hydrochloric acid, and we have a picture here to show what hydrochloric acids look like. Okay, so let us look at weak acids now. So the weak acids will be opposite to the strong acids. So here, the first point is that weak acids are molecules that partially dissociate into ions in aqueous solution. So the weak acids, they do not completely break down or dissolve when in solution. It partially, so not all will break down. The second point, the pH of a weak acid solution is about 3 to 5. So we said just now that the strong acid is from 0 to 3, and the pH of the weak acid will be from 3 to 5. The last point says that weak acids do not release all of their hydrogen ions because they do not break down fully. An example of weak acids would be vinegar, and I have a picture here to show. Okay, so are there any questions on strong acids versus weak acids? Okay, so since there are no questions, we will move right on to strong bases versus weak bases. So I have another chart here. So we have strong bases here versus weak bases. So the first point says that strong bases fully dissociate to give ions in solution. So like strong acids, strong bases fully dissociate, or they fully break down when in solution. The second point, strong bases are indicated by a pH value closer to 14. So, like we said on the pH scale earlier, that strong bases, we can start them from 11 to 14, because the stronger the base, it's closer to 14. The third point, it is highly reactive. So strong bases are highly reactive. Okay, and the last point here are strong bases are high conductor of electricity. And we have a picture here showing bleach. It's an example of a strong base. And remember, we identified bleach earlier on the pH scale as a strong base. Okay. So now we will look at weak bases. And it says here that weak bases partially dissociate to give ions in solution. So like weak acids, weak bases do not break down completely either. The second point, it says that weak bases are indicated by a pH value less than more than 7 but less than 14. So we can say weak bases start from 6 to 11. Also, weak bases are less reactive and they are low conductor of electricity. And we have a picture of an example of a weak base, and this is salt. We also identified it earlier. So, everybody clear on what are strong bases and weak bases? Okay, so before we move on, we're going to look at one similarity between strong acids and strong bases. So, we see here that strong acids completely dissociate or completely break down. Strong bases also completely break down or completely dissociate. And for the weak acids, it partially break down or partially dissociate. And same with the weak bases. They partially dissociate or partially break down. So again, I'm asking, are there any questions on strong and weak acids and bases? Okay, so since there are no questions, we are going to move on to an activity that we have. And this activity is a worksheet. It is based on strong and weak acids and bases. So I'm going to place you into two groups and you're going to work in groups to answer the worksheet. So this group, please come in front here. And those at the back, please come over here. This will be group 1 and over here will be group 2. So here are your papers. Okay, so the first things you are going to do on this paper, you're going to write your name and write the date. Also, you have only 15 minutes to complete this paper. Make sure you read the questions carefully and provide the correct answer in the fill in the blanks, or it also have multiple choice. You circle the correct answer so you can begin working. Okay, so your 15 minutes is up. Let us now go through the paper together. So the first question says, which of the following acids is considered a strong acid? A, acetic acid. B, hydrochloric acid. C, citric acid. D, carbonic acid. So what did you guys do? Okay, so John is saying that he put hydrochloric acid, which is B, and you're very correct. The second question is, which of the following bases is considered a weak base? A, sodium hydroxide. B, ammonia. C, potassium hydroxide. D, calcium hydroxide.
The scale ranges from something to something. Man, go high, man. The answer is on the board. We can see 0 to 14. So that's a giveaway question. So that should be a +1 to some of you. Alright, go. So the next section is the true or false section, and this will be looking at that.
Okay, so for the true or false, that is question. So now we are going to look at question 9. This is true or false. I'm going to read the statement and you're going to tell me if it's true or false. Strong acids and bases conduct electricity better than weak acids and bases. Is this true or false? Okay, very good, group 2. It's true. The next one. Weak acids and bases have a higher degree of ionization compared to strong acids and bases. Is this true or false? Okay, very good. It's false. Let's move on to the next section, and this is a short answer section. This is question 11 we are at. So it says, explain the difference between strong acids and weak acids in terms of their behavior in water. We discussed this earlier, so you should be able to answer it. What is the answer, group 1? Okay, so group 1 is saying that strong acids fully dissociates when it's placed in water, and weak acids partially dissociates when placed in water. So you're very correct. Give yourself a round of applause. Okay, so for the last question, it says, give an example of a common household item that contains a strong acid and explain its use.
That should be very easy for you guys, because we looked at that in detail.
Okay, so group 2 is saying battery acid, and they are saying that in battery acid, sulfuric acid is found there and it can be used in cars. Very good. Give yourself a round of applause. This shows that you understand strong and weak acids and bases. So we will now conclude the lesson. Okay, so to conclude the lesson, I'm going to list some examples of strong and weak acids and bases on the board, and you're going to orally tell me which is strong and weak acids and which is strong and weak bases. here. The first one is sulfuric acid. Can someone tell me if that is a weak or strong acid? Because we know it's an acid because of the acid at the end. Okay, so Sam is saying that it is a strong acid. So yes, you are correct, it is a strong acid. The next one is nitric acid. Do you think that is a weak acid or a strong acid? Okay, yes, this is also a strong acid. Then we have ammonia. Is it an acid or a base? Okay. Okay, so is ammonia a strong base or a weak base? Okay, so you're correct, it is a weak base. Then we have sodium hydroxide. Is it a strong or a weak base? Because it is base. Okay. So yes, it is a strong base. Then we have carbonic acid. Is that a strong acid or a weak acid? Okay, so it is a weak acid. Okay, so we are at potassium hydroxide. So is this a strong or a weak base? Okay, so Sam is saying that it is a weak base. Okay, so that is not correct, but the correct answer is it is a strong base. And the last substance is methylamine. So is this a strong or a weak base? Okay, so yes, this one is a weak base. Okay, so this has brought us to the end of the class. It shows me that you all have a good understanding of strong and weak acids and bases. So now you're going to bring your books up for me to mark and sign and copy the correction if you have to make any correction from the book.